Modern electricity systems are often described as essential utilities, but their structure reflects decisions made long before individual autonomy was a consideration. When large-scale electrical grids were first developed in the late 19th and early 20th centuries, their primary objective was centralized distribution. Power generation was expensive, technically complex, and limited to large installations. As a result, electricity became something produced in one place and consumed everywhere else. This model scaled efficiently for cities and industrial growth. Over time, it became the default framework for how electricity was delivered, regulated, measured, and paid for. Independence was not excluded deliberately, it simply was not part of the original design logic. As energy costs fluctuate and reliability becomes a concern, individuals often look for ways to reduce dependence on centralized systems. Common responses include conservation efforts, partial self-generation, or backup solutions designed for emergencies rather than continuity. These approaches usually operate at the edges of the existing grid rather than outside it. What they share is an assumption that independence can be layered onto infrastructure that was never built to support it. In most cases, these attempts still rely on centralized coordination, standardized compliance, and ongoing grid interaction. The core limitation lies in how electrical infrastructure is organized. Centralized grids require predictability, stable demand, uniform standards, and continuous synchronization across vast regions. Metering systems, billing models, and regulatory frameworks are all aligned with this requirement. Independence introduces variability. Systems that operate outside centralized control are difficult to classify, difficult to regulate, and difficult to integrate into a structure optimized for uniformity. As a result, the grid does not resist independence actively, it simply lacks the mechanisms to accommodate it efficiently.
Historically, alternative energy formats have existed alongside centralized systems. Isolated facilities, remote installations, and specialized environments have long relied on localized generation due to necessity rather than ideology. These formats demonstrate that electricity does not inherently require centralization to function. However, these alternatives were treated as exceptions rather than models. They were tolerated where the grid could not reach, not adopted where the grid already existed. As infrastructure expanded, centralized logic followed, reinforcing the same structural assumptions. Within this landscape, various technologies and systems have emerged that operate outside traditional grid dependence. These are not presented as replacements for the grid, nor as universal solutions, but as structural responses to a framework that was never intended to support individual autonomy. Their existence highlights a distinction, the difference between what is technically possible and what existing systems are designed to accommodate. Whether such approaches are adopted or ignored often depends less on capability and more on compatibility with established infrastructure. Understanding why electrical infrastructure favors centralization requires looking beyond current debates and into the logic of its original design. Independence was not rejected, it was simply never prioritized. The systems in place today continue to reflect those early assumptions. As long as the grid remains optimized for continuity and uniform control, independence will remain structurally peripheral. This does not make it unattainable, but it does explain why it exists outside the default path, and why managing it often proves more complex than expected.